First one is the one on page 27, and I said similar because I altered the question a little bit, giving you the opportunity to do this question independently. I mean, the actual question, try the actual question yourself. So in this question we need to check that in this question we need to check, if you look at the question, it says check that the number r is a solution to this polynomial. That's very easy check. I did the arithmetic here, and if you do the arithmetic, this is 0. So this is truly a solution. You should say that because it's a polynomial which carries all real coefficients, the negative I, which is a complex conjugate of I, will also be a solution. Instead of factoring only linear bracket, we could factor two brackets at once, like so. So we could go after the polynomial Q1 like this, with two brackets at once as a factors, or if you bring these brackets together, it will be something like this. Remember this trick, when you multiply a number with its complex conjugate, it is something like this. And we can go after this polynomial, in fact, with the same division algorithm. I think I have it here somewhere. Here it is. Again, this is just the arithmetic. You can do actually this arithmetic without much my help. In fact, I hope so. But remember, the key here, which saved us lots of time, was the observation which came from class. Is in fact that before, when we know that the root is I, instead of going after the factorization right away, we made this extra step by saying that if the root is I, the negative I is also the root. And that saved us lots of time, because now my factorization, I move it back to the question. Now my factorization is, look at this, x squared plus 1, and then I just copy this polynomial from here, x squared, take 2x plus 10, and now each of these two we can factorize separately. For this one, of course, the solutions, that's the ones which we know before. x1, 2 is plus minus I. For this one, we have to apply formulae for quadratic equations. So if I apply this formulae, it's another opportunity for me to use my half formula. So it will be 1, which is negative, half of the negative b, plus minus 1, take 10 on 1. Or if you do the arithmetic, it will be something like this. This is the factorization. It's already done, factorization over real numbers. This is a done factorization over real numbers. Compare this with the question before. In question before, we first found the factorization over complex numbers, and then we make the step to the reals. Here, the story goes the other way around. First, we found the factorization over reals, then we solved each of these quadratic factors, and now we can produce the factorization over complex numbers. Here it is, x take I, x plus I. That's the first two factors. And the other two will be x take 1, take I, root 3. It's one of these ones. And the other one, x take 1 plus I, root 3. That's the other one of these ones. Now goes your question. Yes, please.
Wouldn't it just be 3 instead of square root of 3? Because you have square root of -9. That becomes 3i.
Yes, it's true actually. Thank you very much. It's just, I don't know why this happened. Let's just kill this. It's free. Thank you very much. And we alter this. Free. Free. Done. That's the correct one.